Hello everyone, my name is Sebastiano and I'm gonna help this course on the GCP Associate Cloud Engineer certification. So let's start from the very beginning, meaning let's start from the training overview. What does the course include and how will it be composed, basically? So, I mean, as the title already says, the course is a course that should help you to take the Associate Cloud Engineer certification. So, here on the right of the slide, you can see basically the definition of an associate cloud engineer taken from the Google definition itself. But basically, this certification is, in my opinion, let's say the first certification a cloud engineer working on GCP should take, because it's like the basic one. Like after you have taken this one, I mean, you can kind of understand it also from here. If you go on the page where I guess you have been already, where there is like all the resume of all the certification, you will see that basically this is, let's say, the kind of basic one, and then you have all the professional ones. So you have like professional cloud developer, professional data engineer, professional cloud architect, and so on and so forth. And we will start from this one. So basically this course will be, all this video will be just related to the associate cloud engineer. Then I think I will do another video for the professional cloud developer one, but I mean, that's another thing, and in case you will see it in another video. And we will follow the official book. So there is a book which is called Associate Cloud Engineer. It's a very big and extensive book. It includes more than 500 pages, and in my opinion it's probably even too verbose for what you probably need. I mean, it's a super great book. I personally studied from it also, but I also have some kind of hands-on experience. And so together with the book, I'll try to let you have this hands-on experience on GCP, right? Because GCP gives you basically, I think, up to $300 for free, let's say. So the first $300 you don't pay, so you can test it by your own. And so during the video, you will see myself doing stuff on Google Cloud Platform, so that if you don't know how to do something, you can see how I will do it and let's say replicate it and learn with me. Or if for any reason you cannot do it by yourself, I mean, you will just watch me. Of course, I advise you to do it as well. And at the end of every lesson, there will be a question and answers review that we will do together. Again, I mean, I will let you do first, and then we will see the answer and we'll try to understand why those are the correct answers. So I think that's it. A few questions about me, because like personally, when I follow a course, I always want to know who is the teacher, which competencies he does, to understand, I mean, if he is actually, if I should follow the course or not, right? So as I said before, my name is Sebastiano Di Stefano. I'm from Italy, and this is, let's say, my experience up to now. So first of all, I took a computer engineering bachelor degree in the University of Catania. This nice elephant is the symbol of the city. Then, as unfortunately many people do in Italy, I migrated from Sicily to north of Italy, and I took my master degree in Polytechnic of Turin, still in computer engineering. While I was doing that, I decided to do an Erasmus, which I did in Eurecom. So Eurecom is actually the campus for foreign students of Telecom Paritech. So actually the university is called the Telecom Paritech. Anyway, I got the double degree, so from both the university, and after that I started an internship in Amadeus, a company located in the south of France, and then I worked there for other 2.5 years, something like that, where I was basically a Java developer. I mean, the title was software development engineer, but I was mainly, let's say, a Java developer. And then I decided to go back to Italy, and I started working for another company, much smaller size, called Bending Spoons. This is where I'm currently working at the time of recording the video, of course. And here I interact basically daily with Google Cloud Platform. That is why I decided to take the certification, and then also to do some video to help other people to take it. Okay, So we can go on the lessons of today. So again, as I said at the very beginning, so how do lessons work? So I will try to have the lesson as hands-on as possible. I promise I will try to do a lot of practice, because I think that you can know all the theory you want, but without practice, sometimes you don't really understand things 100% well. Just bear with me. This first lesson will be just theory. I'm super sorry about that. I'll try to not be boring as much as possible, but it will be just theory because, well, as again, I will follow the structure of the book. Today's lesson is the first 2 chapters. There is nothing practical there, but we will do it in the next lesson, all right? And again, it's super useful. I mean, also, again, practice is very important. You need to practice to understand something at 100%, but sometimes before practicing, you need to have some basic knowledge. So that's what we will try to get today. And so these basically correspond to the first 2 chapters of the book I presented before. So we will see an overview of GCP, types of cloud services, cloud computing versus data center computing, and then Google Cloud Computing Services, where we will see from a high level point of view for today, but then we will go in details, of course, in the next lessons, a lot of stuff really, like computing, storage, networking, and additional components of GCP. So let's start. Cloud versus data center. This is, let's say, the eternal dilemma that you will find in every cloud-related presentation. Well, it's not really a dilemma, right? It's actually most of the time people trying to convince you that cloud is better than data center, which is probably true in 99% of the situations. And here we'll try to explain why. So there are a couple of 4 points that I put here. So first point, actually the first 2 are very related, is rent versus own resources. So basically when you own your own data center, of course you own the resources, right? But that's something that it's pretty hard to do if you're not a big company, probably, because you need to invest a lot of money for the resources, and moreover you need to know how much money you need to invest, right? I mean, because maybe you buy the things today but you want to use it in 5 years, so you need to know that in 5 years you will need I don't know, a lot of servers, like 1000 server or maybe 5000 server, how do you know? So that's a very important point. And moreover, this is very linked to the second point, pay as you go for what you use. What does it mean? Like imagine the classical example, you have an e-commerce, all right? And this e-commerce, like, I don't know, you have 1000 active users per day, but then Black Friday comes and on that weekend you have 10,000 users. What are you gonna do? If you have a data center, you have 2 possibilities. First possibility is like on Black Friday, you have an outage because you cannot handle that many people and you lose a lot of money. Second possibility is you have to pay the servers to support 10,000 users forever, like for all the year. You cannot just pay them for the Black Friday and then say, oh, you know what, I will give it back to the seller. Yeah, you cannot do that. So that's basically the problem. You don't have flexibility. Cloud providers give you this flexibility that instead you don't have with data centers. So that's another very important point. Also imagine you are a startup, or not a startup, but I mean you don't have a lot of resources to invest in a data center. Well, having the cloud, a cloud provider like GCP or like AWS or Microsoft or whatever you prefer, it really it makes things much easier for smaller companies, because again, you don't need to pay for the people who need to handle that stuff, which is a considerable amount of money. That if you are a company in the first ages of life, in the first years of life, it's probably a cost that you cannot cover, right? So yeah, that's basically it. Then elastic resource allocation. That's another important point, because if you have your own data center, the resource allocation is not that elastic. Before I talked about flexibility, here by elasticity I mean that provider like Google Cloud Platform, but not only, it's the same like with AWS once again, gives you a lot of elasticity. Let's say that, for instance, you need to start, I don't know, 30 servers in a couple of minutes. You can do that. If you have your own data center, it's not that easy, trust me, you cannot do that easily. So that's another important point. Elasticity, it's very important in a lot of situations, really. And finally, they provide specialized services, like they provide a lot of, as we will see, I don't know, in a few minutes, or maybe in the next lesson, they provide a lot of services, like, I don't know, GCP provides services for machine learning, let's say, for natural language processing, for AI, for whatever you can imagine. Basically, yeah, whatever you can imagine, they have it. So a lot of specialized services, basically stuff which is serverless, and you just go there and use it. You don't even know how it works behind the scenes, but it just works. Stuff that you don't have, of course, with a data center. So really, honestly, the advantages are a lot. It's not just that I want to sell you the product. I don't care. I'm not paid by Google, right? We're just saying things as they stand. And so let's see what are the types of cloud services. I would say we need to start with compute resources, right? Because like most of the time, even if you are, let's say, a solo developer, you're doing your own application and you want to deploy it. Well, the first thing you need is a server. You need to deploy the application somewhere. And this can be done in different ways. So here we present the three main products, and before even talking about them, I want you to remind something. We are not saying like one is better than the other one. They are all great products, but sometimes you need to use one, sometimes you need to use another one. That's actually how the whole associate certification will be like, right? I mean, as a cloud associate engineer, you need to understand which product is better for your need. It's not that like virtual machine sucks and serverless computing is perfect, because you might have some needs for which virtual machines perfectly suit and serverless computing is just a huge expense that you want to avoid it. So now let's go a bit more in detail. So virtual machines, how do they work? So virtual machines are fully customizable. Basically, it means that you, the engineer, have to take this virtual machine and you say, you know what, I want a virtual machine which runs on Linux, and I want to run this other guest operating system on top of it. I want to give it 6 GB of RAM. I want to give it 4 CPUs. I don't know, 200 GB of storage, whatever you can imagine, you can customize it. Really, you have plenty of choices from this point of view. But this, of course, means that you need people to handle that, right? You need a configuration to handle. So that can be, again, a pro, it can be a con. It depends from what you need to do. In some cases, you want that. In some other cases, you don't want that. But yeah, that's so the main characteristics. And then we will go a bit more in detail of virtual machines. And then they are integrable. Sorry, sometimes it looks like I watch in another direction, but it's because actually I have two screens. So the screen where I have the slides is on that direction. And so I was saying it's integrable with load balancers and autoscaler. What does it mean? So should be pretty easy to understand, I guess. So the load balancer, it's, let's say, in a very raw way, it's a kind of machine that you put like in front of your all machines. It receives all the requests and it balances the traffic between machines, so that you don't have the machine A which has 200,000 requests and machine B which has 5 requests, right? The load balancer balances the machine among them, and then you can provide some more specific configuration apart from just balancing the machine. But for the moment, let's just say that this is the job done by the load balancer. And then there is also the auto-scaling. So basically the autoscaler is, let's say, another component which can, based again on the workload, add or remove virtual machines. So what does it mean? What does it mean? It means that, for instance, you can say, okay, normally I want 4 VMs, but once the percentage, the CPU percentage touches 70%, I want to add the 5th one. And if it is still 70% on average, let's add the 6th one, and so on. Or when no one used it, vice versa, let's go back to 4. Maybe, I don't know, you can also say I want at least 2, even if no one uses it, I want at least 2 machines, just to be safe. And as soon as people start using it, again, according to the CPU, according to the RAM, it's, again, really customizable. You can specify how the autoscaler works. We will see it better later, also, again, hands-on, don't worry. Then we have the second possibility. So the second possibility is manage Kubernetes cluster. So, super sorry. So the managed Kubernetes cluster, it's basically a kind of middle solution between virtual machines and serverless. Why that? Because so we can basically say that virtual machines is basically infrastructure as a service, and serverless computing, as we will see, is basically platform as a service. So managed Kubernetes cluster is, again, kind of in the middle, because it allows you to focus mainly on the application, but not only. There is still some stuff that you need to configure. And okay, Kubernetes, maybe you already know what it is, maybe you don't worry, because again, we will see it more in detail later. But Kubernetes, basically, it allows you to run your application on container only, so it has to be containerized, which most of the times I guess it will be the case if you live in 2021 as I do. And oh, sorry again, I don't have to touch the mouse anymore, I guess. And again, you can put some configuration, but at the end you have the CMS, so the container management system, which will take care of everything. So basically it will take of auto-scaling, of monitoring, of the auto-heal, everything. You can, again, configure it, of course, but let's say you have less stuff to care about compared to the virtual machine, less stuff to configure. Oh God. And then you have the serverless computing. So serverless computing, full focus on the application. Once again, what we said before. So you are the engineer, you just focus on your, I don't know, what is it? A Python application? You know just Python, you don't know anything else. Then you take the Python application and say, okay, it has to run here. Like I did this thing once, I didn't do it on GCP, I did it on Heroku. I took my application, I said, okay, it was like a super stupid application. It was a Telegram bot written in Python, put it there, it was running. I didn't know at all which machine was running, which RAM it had. I had no idea. I just put it and took it and put it there. And so in terms of serverless computing, we will see mainly 2 solutions, App Engine and Cloud Functions. And don't worry about it, because we'll talk just in a few seconds about both of them. Really, guys, I'm really sorry about this mouse. So, Compute Engine, let's talk about these solutions first. So first of all, as you can see here, we have a wonderful image on the right. I think like every person who has studied computer science or computer engineering has seen this image at least 200 times in his life. So this is the image of the VM architecture. So it is not the topic of this course, but VMs are important, so I will still see a couple of words. I guess you already know most of the things, so in case, Google. So, how does the architecture look like? So, you have the physical server, which can be, I don't know, a machine where you have 4 GB of RAM, whatever you want, and on which there is an operating system which runs. Let's say, I don't know, Ubuntu 17 is running there. Okay. Then you have this component. The component is the hypervisor. So what is the objective of the hypervisor? The objective of the hypervisor is to take these 3 blocks, in this case there are 3, they can be of course how many you want, and say, okay, you can run on the same physical server, and this first guy doesn't know anything about the second guy and about the third guy. So they are completely isolated. So the first guy, what is it? is actually another operating system. So this is the host operating system, this is the guest operating system, which is in this case Ubuntu Linux, in this case Alpine Linux, in this case Windows Server. It can be whatever you want, Mac, OS X, whatever, OS X without Mac. And then you have the application that runs here and here. So this is basically how things worked for a lot of time. Like until a few years ago, this was the most common configuration that where all the application websites were running, right? It was, let's say, before the container took the scene. So why at a certain point this stuff, let's say, kind of disappeared? I'm sure there are still plenty of people using it, probably also big application, maybe most probably, I guess, for legacy reasons, but still, this is still present. Not only for legacy reasons, there are quite a few reasons for which you could use it. I remember, like, for instance, in my previous job, we were using mainly VMs, but anyway, the reason why this stuff started to disappear in favor of containers is because it is heavy, right? You have like an operating system on top of an operating system, and this thing make the whole architecture not so light. Machines are a bit slower in startup. There are really plenty of reasons. Again, we don't go in detail here, but I'm sure you will find a lot of articles about it. But okay, now that we explained the picture that you probably already knew, what can we say? That Compute Engine is the infrastructure as a service of Google Cloud Platform, and we already said it before, that you can customize everything, really everything you can imagine, and we already said it before. And then we have this third point, preemptible VMs. So preemptible VMs is basically another feature offered by GCP, by Google Cloud Platform, that basically tells you, okay, you know what, rather than using a normal VM, you can use another kind of VM, which is called preemptible. What does it mean? It means that this VM will cost much less than a normal VM, like 80% less, so crazy less if you have many. It's really a lot of money saved, but the VM can be shut down at any time by Google. So, like, especially if it has been running for at least 24 hours, it can be shut down really frequently. So what does it mean? It means that if you have to take your website, your web server, in a preemptible VM, that is a very bad idea, because at any moment Google can say, okay, you know what, your website is down. You have to accept it, because you paid for 80% less. So it means that here you have to run stuff which is not critical, right? Which if you do it now, or if you do it in 3 hours from now, no one cares. That's the use case of preemptible VMs. So it's probably not a very common use case, but still there are cases in which you can use that and you can save plenty of money. Next, it's nice that when I don't want to change slide, it changes, but when I click because I want to change, I need to click twice. Okay, Kubernetes engine. So again, here I'm not gonna go in detail of Kubernetes because there will be another lesson where we will only focus on that. But we need to know that, as I said before, they are based on container only, right? You cannot take an application which is not containerized and make it working on Kubernetes. It has to be containerized. So here it's the counterpart of the VM that we said before for container system. So you have the host operating system. You don't have a guest operating system, but we have a container. There again is isolated, and you have the container manager, which, as I said before, is in charge of isolating them and make them run much lighter, much more used nowadays. So these containerized apps run on a cluster of servers. They are configurable by a command line interface or also by graphic interface. So as I said before, there is again some configuration, of course there is, but it's much less than with Compute Engine, where you really have to specify absolutely everything you need. And I mean, it's not just that you need to specify, you need to know which kind of physical server you will need. Right here, you don't. You can say to GCP, okay, I will tell you those 2-3 things that you need to run them. Everything else, you will take care of it. But we will see better the difference once we put hands-on both of the services. Will really understand at that point 100% well what's the really difference. And again, this container management system, the CMS, will take care of, we already said it before, of automatic monitoring, of scaling, of everything you will need. Finally, platform as a services. So we talked about it before. Here we present two different solutions, App Engine and Cloud Functions. So they are both serverless, and I want to specify one thing now and don't say it anymore. When I will say serverless, it doesn't mean that there is no server behind, right? It wouldn't make sense that way. I mean, the code has to run somewhere, there has to be a server behind. Serverless means that you don't care if there is a server behind, because it's Google in this case that handles it. So these two solutions, App Engine and Cloud Functions, are serverless because you don't need to know that there is a server or there are 20 servers that are running behind. You only need to know the details of your application, not of the infrastructure. And here you have two solutions. Let's talk about App Engine first. So App Engine is quite similar to what we presented up to now, but again, it's serverless. So you don't need to specify anything, really anything, like there is nothing to configure. You just take the application and say, okay, run here. But there are two types of App Engine solutions. There is the standard one and the flexible one. So what's the difference? In the standard environment, you run the application in a language-specific sandbox, so that the application is isolated from the underlying server's operating system, as well as from other applications running there. What does it mean, this so complex sentence? Basically, it means that the application can be non-containerized. It will be written in, I don't know, in Python, in Java. It has to be a language which is supported by App Engine, but if it's like one of the most used languages, it will be. And so you will take it and you will say, okay, run here, without containerizing it. You don't even need to do this additional step, just run here. And this sandbox offered by Google will take care of isolating it from all the rest and from installing like all the packages you need and from doing everything you need. That's it, really. And while in the flexible environment, which as the name itself says is more flexible, you can run Docker containers instead. So this works well where you have the application code, but also you might need, I don't know, libraries or other third-party software installed. And it gives you basically more options. So there is slightly more things to configure, but really not much of it. Just you need to know that it's basically for containerized application. What about Cloud Functions instead? Cloud Functions, they are a bit different because Cloud Function, they are again serverless, but they are well suited for event-driven processing. So basically there is an event coming, let's say a message from okay, maybe you don't know what is PubSub, from a message queue. Even if you don't know what is a message queue, an event, okay? Let's imagine there is an event coming, can be something that happens every day at 11 a.m. or something that you don't know when it happens, but it can happen today 3 times, tomorrow 1 time. Okay, there is some event happening and you need to execute some code in response to that event. And this code, it has to be like that you have to execute, the task that you need to execute has to be short running, right? It cannot be like 24 hours of task, otherwise it will be like using App Engine again if it's like a web server running. It has to be something short, where short can be, I guess, even a couple of hours. Most of the time probably it will be less. But anyway, you need to do something in reply to this event. And yeah, most probably you're gonna pay less, right, than App Engine, because basically your code will not need to run all the time, but just in response to these events. And yeah, I think that's it. So let's now talk about the storage, right? The storage resources. So storage resources can be really of different type because there are actually a lot of possible use cases. So here we will try to first in this slide talk about the possible storage resources indeed, and then we will see the services, the products that Google gives you according to the kind of storage that you will actually want to use. So possible storage resources are, first of all, there is the object storage. So object storage, what does it mean? It means basically that you are storing objects, which most of the times will be files, and these objects that you're storing are addressable through URLs. So if you are already familiar with cloud storage, as we will see in a few minutes, you probably already understood what we are talking about. But basically, you will have like serverless solutions like cloud storage that allows you to store stuff either here or there, and then access this stuff, these resources through, again, URL, through unique identifier. Then you can also specify like access policies, for instance. So you can say like actually the access policies are defined mainly in the buckets, right? Because what I didn't say is that these objects are grouped into buckets, and so you will specify the policies to access the bucket as you wish. Then we have file storage. So file storage instead is a completely different need, I will say. It is based on the NFS, the Network File System Protocol, and it basically provides operating system like file access. So you will have the directory structure. It's basically used like in NAS and this kind of solution. So it's something actually quite different, I would say. Sorry. From the first solution. Then we have block storage. So block storage, again, it's a bit different from before because the data in this case are structured into blocks. Let's do, well, the two examples that they've written here. So blocks, basically they can be, first of all, of any size, right? It can be 4 kilobytes, but they can be also quite big. It depends. Like in Linux, usually it's 4 kilobytes, but it doesn't have to be. And so it can be for disk attached to VMs, and this disk, they can actually be either persistent or ephemeral. So if they are persistent, it means that even if you shut down the machine, for instance, the data are still there. If they're ephemeral, the data are gone as soon as you shut down the machine. Or databases, but that's completely, I mean, that means that database access data that are structured again in blocks. Actually, the database management itself structure the data into blocks, but then you access them through a completely different way, as you probably know, when using a DB with a query language. And we will see later what are all the possible solutions also for this use case. And finally we have cache. So cache are of course in-memory type of storage, so much quicker when you need to access data with a really low latency, like really, when I say really, it's because I mean like order of magnitude, as again you probably know, faster with respect to other solutions. So they are very quick. The bad thing is that they can get out of sync with the system of truth, because most of the times if you have a cache, you have also another storage system, unless you don't have a lot of data, and then okay, you just have the cache because it's enough. But most of the time it's not that way. You have a lot of data, and caches are really expensive, so you can put in the cache only a part of the data. That means that you need somehow to handle the synchronization, right, between the cache and the system of truth, whatever it is. Maybe it's a database, maybe it's something else. This can be sometimes pretty hard. We won't go in detail on how to do that because it isn't really related to the certification, but just imagine that there are books just about how to handle this particular use case, okay? So that's not something as easy as it may seem. So up to now, let's go to the next slide. Up to now, we have presented let's say the resources. Now, I think it's more correct to define, to talk about them as the services, or if you prefer, as the products that are offered by Google to handle this kind of storage resources. So the first, which is probably, I guess, also the most the well-known really product, is Google Cloud Storage. And Google Cloud Storage is basically an object storage system, so provides access to the first type of data we described just before, so to objects. And it has a few characteristics. So the first one is that it's serverless, as we said, and then you don't already know, unless, I mean, you know it because you already knew before following the course, but I didn't say it yet. I will go more in detail again later about this, but Google is let's say, structured. Its structure is some of its resources into regions and zones. So basically a region, which is an actual geographic region in the world, can contain some zones inside. So most of the times, I mean, it depends of course, sometimes, let's say, you want to say, okay, you know what, I want to store my data in this zone, which is inside this region, in this zone A, which is inside the region 1. But then I want replicas. So the replica can be also inside the same region. But if you have quite important data, you probably want to have regional replicas. Otherwise, it happened to me actually not so much time ago. I received an email, I don't even remember from who, because it was something that I haven't really used that much. There was some data center in Europe, somewhere in Europe, maybe in Germany. Anyway, there was a fire and they lost all the data. Probably these guys, they didn't really do a lot of regional replicas. No, regional replicas are mainly for that reason. When there is an outage, an important one, it could be a fire, it could be an earthquake, like terrible things, like, and then we will go a bit more in the disaster recovery section, right? But anyway, when something like that happens, you probably want your data to be located in more regions, so maybe both in Europe and in US. At worst, US collapses, let's say, you have the data in Europe. Let's hope that it doesn't happen, but anyway. Anyway, cloud storage allows you to specify, to configure this quite easily, and you have access to the data with relatively low latency. Of course, it cannot be the same as if they were located on the same machine. That's, I think, quite normal, right? Networking is always the worst part in terms of performances. Then we have a persistent disk. Persistent disk, instead, it's actually, I already said it before, I already anticipated it, basically corresponds to SSD and hard disk. I think everyone knows SSD are faster than hard disk, but they are also more expensive. They can be, again, ephemeral, they can be persistent, and they can be of many sizes according to how much you pay. Then we have cloud storage for Firebase. So this is more is again a kind of object storage, but for a reliable connection, such as the one for mobile devices. Basically, this allows you to say that if you have a mobile device, if you have a reliable connection, you can still manage the transfer of data in a much easier way without having to handle by yourself a lot of the logic for retransmissions or stuff like that. It's much more robust, let's say. It's generally used for this kind of solution. And finally, at least among the one that I'm proposing, the most famous one, there is Cloud File Store. Cloud File Store, in this case, it's more for a file system-based solution, so more for NAS, as I was saying before, based again on the NFS protocol, and used here I brought used for grained objects retrieval, because it's mainly like when you want to retrieve, for instance, a full image, right? You don't want to retrieve a part of an image most of the time. When you want to retrieve part of objects, usually you use a query language, and so here we go in databases. This is not the case for file store. Here we're talking about files. But since I just anticipated them, let's talk about databases. So databases, there are so many solutions concerning database because there are so many use cases, right? So let's review all of them with calm. Let's try to understand them well. So first one is Cloud SQL. So Cloud SQL, it's basically provides a relational database. Actually, only MySQL and PostgreSQL are supported for the time being, but they are the most used probably. So MySQL, there are actually two generations. There is like the first generation, which is the difference between the two generations is just that the first generation has like it's less powerful than the second one. Let's put it this way, and because the second one you can have like higher data storage, higher RAM, these kind of things, and PostgreSQL, which it's kind of correspondent to the second generation of MySQL. And I guess I don't have to say a lot of stuff about relational DB because you already know that they support transaction, indexing. They're basically when you need a relational database, when you need this kind of how can I say it? Of features. Sorry, I didn't find the word. Then you have Cloud Bigtable. So Cloud Bigtable is quite different. Instead, it is mainly for when you have to access petabyte scale applications that can manage so really millions of rows, even thousands of columns, and it is based on a NoSQL model, which is called the wide column data model. So it's completely another use case with respect to Cloud SQL. Then we have Cloud Spanner. So Cloud Spanner, you can think about it as Cloud SQL, but more powerful because it's like Cloud SQL. It's relational. It's a relational database, but it is distributed and it gives a lot of like 99 dot I don't know many 9% of availability. So that's great, and it is able to scale horizontally. So that is why it gives this availability, thanks to the fact that it has a kind of NoSQL structure, even though it's relational. Then we have Cloud Data Store. Cloud Data Store again instead is a NoSQL, so it's taught for storing documents, but at the same time it supports a few things that you usually find in relational DB, such as transaction and indexes. But it's mainly used when you need the NoSQL, right? So those situations where, for instance, you need to store documents, or you need you have access, you have data for which you don't really know a priori the structure that they are gonna have. And so in that case, you have much more flexibility using NoSQL, because you can store today this kind of data, tomorrow the data change completely, you can keep storing them without modifying at all the DB. It really depends from the use case, of course. Then Cloud Memory Store, here I put Redis because it's the classical example. Redis is actually Redis can be used in different ways in GCP. Cloud Memory Store is, let's say, the easiest one, so you don't have to configure much. You have it there in GCP, you use it as a cache, and then Redis, again, it's quite powerful tool, actually developed by a great engineer who lives just a couple of just some kilometers away from where I'm currently located in Sicily. So great tool, again, depends from the need, of course. Finally, Firestore. Again, this fire prefix should remind you about Firebase, and it indeed is a NoSQL DB for web and mobile application that basically allows you to have real-time updates in the mobile device, for instance, even when you are having changes in the backend. So it is more, again, for those kind of devices according to what you need to support, of course. And I think we did quite a very, of course, high-level overview, but it's a lot of stuff, really. So in a few minutes, we cannot say much more than that. We will see more in detail what we are interested in the next sections, in the next lessons. But we did quite a high panoramic of the storage part, of the database part. Now let's talk about something else. Let's talk about other resources, mainly networking and specialized services. So let's focus on networking first. I didn't put a lot of stuff here, but actually networking is, again, quite a powerful tool, very configurable, because networking provides you with what is called a VPC, a virtual private cloud. Basically, you can do a lot of stuff, but to simplify, you basically take a range of IP addresses and you say, okay, I want to use this IP addresses range. And then in the machines that are in this VPC network that you're gonna create, you can assign the IP private, or I mean, they can be automatically assigned according to the addresses range that you have chosen. You can also assign external IP addresses. They don't have to be private. Public. I don't know why I say the external. Public IP addresses. They don't have to be private. And you can specify firewall rules for to say how these machines have to interact between each other or between external services. So you can specify, again, a lot of stuff. And also like VPC peering, if we want two different networks to communicate between each other. So again, quite a powerful tool. You can specify a lot of stuff on it, and it's very useful, and actually you're gonna need it for basically anything you need to do. As long as you have, you need to use, for instance, compute engine, you also need a VPC network where the machine have to be run, right? So you're gonna need also that one. And then we have specialized services. So specialized services, there are plenty. They're basically services. Here I will just say that they exist. Then we will talk about them a bit more in detail later. But it's basically specialized services are like serverless. So again, you don't need to configure almost anything. You don't need to know how many servers they're running, nothing. And they are of various types. Here, actually, the example I put are all machine learning like, so AutoML, Cloud Natural Language, Cloud Vision. It's basically when you need to do something, for instance, I don't know, you have a text, you have an image that contains a text and you want to translate it into text, you don't know how to do it. Probably there is a service offered by Google that allows you to do that very easily, even though you don't know in practice what is the algorithm used to do it, but Google allows you to do it with a specialized service, which is serverless. You don't need to know, again, how many servers are running behind to do this translation. You just take it and use it. That's it. This is like a classical example, I guess. And there are a lot of them, like Google adds them with quite a high frequency. So probably today, while I'm talking about, there are 50 of them, and then tomorrow there will be 55, and in 1 year you will have 100. Sorry for the background noise. But let's say one step back. Let's keep talking about networking, because what did I say about networking? I talked about VPC networks, and I talk about firewalls, mainly. That's what I said. I also said a couple of words about VPC peering. But there are actually quite a few solutions, again, proposed here by Google, which are, let's say, in the range of networking components. So one of them is Cloud Armor. So Cloud Armor provides basically a few things to defend, let's say, yourself from malicious attacks. So for example, I don't know, from distributed denial of service attacks. It provides you quite a few stuff. For instance, you can prevent or give access based on IP or geolocation. it allows you to prevent SQL injection, let's say, out of the box. It allows you to define network rules at level 3 or 7 of the network, so network level or application level, and a few other stuff. So it's mainly, let's say, a security measure that you can give, or you can just implement it by yourself, of course, but with Cloud Armor you have it out of the box without having to lose too much time to think about it if you forgot something or not. Then you have Cloud CDN, which is basically the solution for content delivery network. Content delivery network, I guess you already know what they are. It's basically a way to, they're basically a technology to provide low latency response to content across the globe. So, for instance, to access, when you have, I don't know, a solution, the classical example is the news website that provides a lot of statics, so I don't know, a lot of files or videos, and these have to be distributed across the globe quite quickly. You can do that thanks to a content delivery network. So, I mean, nothing incredibly, I guess, right? It's just, if you know that content delivery network exists, here I'm just telling you, okay, GCP has a solution for that. Then we have Cloud Interconnect, which is a way to interconnect networks. Before I talked about VPC peering. Here it's mainly to say that you can interconnect like your own network with, for instance, an external data center network, not just with other networks inside the GCP, because in theory you could do also that. You could have different projects. We didn't talk about projects, but if you use the GCP at least one, you know already what projects are. If you didn't, don't worry, we are gonna find it out. But basically we have products. Sorry, I hope I'm not boring you because I told you so much unfortunately without again putting our hand dirty on the stuff, but I promise we will do it soon. Anyway, so yeah, you can do it. You can do VPC peering when you have to take two networks inside two GCP projects and you want them to interact, or you can say that you want your network to interact with a network from, for instance, a data center outside of GCP. And in that case, you can do that with Cloud Interconnect. There are a few ways to do it. For instance, you can have a direct access, or you can do it through a third-party services. In that case, it's called Partner Interconnect. Or if none of them are possible, you can also use just the VPNs. It depends again from your needs, of course. Then you have Cloud DNS. Okay, the DNS, you all know what it is. So again, it's just the GCP solution for DNS, and it is designed to scale. You can also use it for private zones that allows you to create custom names in a few cases. Finally, I promise we are almost over. I think this is the last slide. Let me check. Yes, then there are questions. So this is the last slide. So in the last slide, I'm gonna talk from a high level point of view again, unfortunately, about basically everything that is left. So let's start one by one. So identity management. Identity management basically is let's say a safety way. Don't know if it's the correct way to say it, but basically it allows you to say which user, which identity can access what. So for example, you can say that I am defined by my own email, so sebastiano@gmail.com can have a particular role or a particular permission. We will see later what roles and permissions are, but basically you can imagine that a role is a set of permissions. So for example, I can have a role that is compute engine admin, and then this inside has a few permissions like shutting down a machine, starting a machine, updating a machine configuration. Or I can have a role that is a bit let's say less powerful, that can maybe just visualize all the machines, but this permission at the same time is included also in the admin role. Okay, so the identity management is basically this kind of system that allows to give access to particular users to what they need. Let's put it this way: user, they don't have to be persons. They can also be applications. We will see it in other sections. Okay, for the moment this should be enough to know. I'm sorry. Then we have development tools. So that's it for the identity management for the moment. Then we have the second point, development tools. So development tools are again another set of tools offered by Google. So there is Cloud SDK. Cloud SDK is a command line interface that allows you to manage basically everything you can imagine about the GCP. You have the SDK, you install it, command line, and you do what you need to do. In some cases, this is the best way to deal with GCP. In some other cases, it's not. We will see when. But this is Cloud SDK. You have the container registry. This is where, for instance, you store the Docker images. Or you have cloud source repositories, which basically allows you to do version control. You can have some plugin to basically have a kind of, let's say, IntelliJ on GCP. I mean, not on GCP, but integrated with GCP. So a lot of stuff. Then you have also the management tools. Management tools are again another set of tools, products. These are all synonyms in this case, offered by Google. Here I reported the most important ones. So, but of course there are really so many that I cannot talk until tomorrow about them. So there is, for instance, TechDriver, which is a service that collects metrics, logs, even data. Then there is monitoring, which extends basically the capability of TechDriver by collecting performance data from GCP, but not only, or you could also take them from AWS. Then there is logging, which basically store, consolidate, analyze logs. And then there is error, and I said and, but as you can see, there are the 3 points, which basically are here to say there is much more. Error reporting aggregates application crash information. Then we have specialized services. Please stay with me just other 5 minutes and then there are questions and things will be a bit more funny. Specialized services, again, there are a lot of them. We will see just a few. So first one is APIG. So APIG is again a service that can be useful if you are providing an API because it allows you to handle, without having to configure it too much by yourself, stuff like authentication. For example, you could say that thanks to APIG you could give OAuth 2.0 authentication, or also you can handle in a much easier way load balancing. So also when there are like spikes, it also provides routing, rate limiting policies. So it's usually more for API and probably quite API that needs to handle quite some traffic. If you're doing an API for a private tool that will be used by 3 people, probably is an overkill. Then there is data analytics. So inside data analytics there are a lot of stuff that have so many similar names. So the first one that I actually forgot to put in the slide is BigQuery. Name different from all the other ones. So BigQuery is a database service that it's mainly used for data warehousing, again petabyte data. We will see later, we'll talk later about it. Then we have Dataproc, Dataflow, and Dataprep. One by one, just 2 words for all of them. So Dataflow is a framework for defining batch and stream processing pipelines. Dataproc is managed Hadoop and Spark service, and Dataprep allows analysts to explore and prepare data for analysis. Now don't worry too much about the difference from all of them, because of course with 3 words you cannot be an expert of it. Just need to know that they are data analytics tool. Probably that's enough for the moment, and we'll see later. And then there are other ones like I talked about them before for machine learning, such as natural language processing, cloud vision, and so on. Okay, that was hard, I admit it, probably boring, but let's finally go to the questions. All right, let's go to the juicy stuff finally. So our review questions. So my advice for you is, that's the way I'm gonna do that. So we're gonna see the question, I'm gonna read them one by one and say what's the correct answer. So please take your time to stop the video, answer by yourself, and only after that I will go to the questions. I will say what are the answers. Okay, right? I'm going to read them and to give the answer. So please stop the video and only resume it when you replied, when you answered. Okay. So, what is the fundamental unit of computing in cloud computing? Physical server, VM, block or subnet? So I will say block or subnet. Absolutely not. And the answer is B, guys, because the fundamental unit it's clearly the VM. No, that's what you're gonna rent. Basically, you're not gonna take the physical server, but you're gonna take VMs. That's true in GCP, but it's also true in other other providers like AWS. Then, if you use a cluster that is managed by a cloud provider, which of these will be managed for you by the cloud provider? Monitoring, networking, some security management task, or all of the above? Clearly, it's all of the above. This is also easy because when you took a cluster, as we said, for instance, I don't know, with Kubernetes, GCP provides everything out of the box for you. That is the advantage, right? That you don't have to do it by yourself. You need serverless computing for file processing and running the backend of a website. Which two products can you choose from GCP? So we want serverless, right? And we want file processing and running the backend. So answer A says Kubernetes Engine and Compute Engine, but Compute Engine is not serverless, and actually also Kubernetes is not exactly serverless, so this is not the answer. Then we have App Engine and Cloud Functions, which might be true. Then we have Cloud Functions and Compute Engine, not true for what we said here, and Cloud Functions and Kubernetes Engine, not true. So the answer is B. We have been asked to design a storage system for a web app that allows users to upload large data files to be analyzed by a business intelligence workflow. The files should be stored in a high availability storage system. File system functionality is not required. Which storage system in GCP should be used? So, we want it high availability and we don't need file system. So, it's not D, network file system, it's not cache, because anyway it's large data, it cannot stay in cache, so it will be either A, block storage, or B, object storage. But in this case it talks about large data files, file system. Okay, so since it talks about storage system, sorry, already clicked, about large data files, it's object storage. Then all block storage system use what block size? So if you remember what I said, I made an example of 4 kilobytes with Linux, but it doesn't mean that it has to be 4 kilobytes. As we already said, block size can vary. 6. Sorry, you cannot see it with my, only now I realize it. 6. You have been asked to set up network security in a virtual private cloud. Your company wants to have multiple subnetworks and limit traffic between the subnetworks. Which network security control would you use to control the flow of traffic between subnets? Well, okay, think about it, fine. It's a firewall, right? That gives you the ability to control the flow of traffic between subnets. Then, 7. When you create a machine learning service to identify text in an image, what type of servers should you use to manage compute resources? I made this example, I think, a lot of times. you use, in this case, specialized services, right? Which are serverless, therefore no servers. 8. Investing in servers for extended period of time, such as committing to use servers for 3 to 5 years, works well when a company is just starting up. I would say absolutely not, right? A company can accurately predict server need for an extended period of time. Yes. The budget, even if either if fixed or variable, doesn't have any validity, so it's B. 9. Your company is based in X and will be running a virtual server for Y. What factor determines the unit per minute cost? The time of day? No. The characteristic of the server? Yes. Even if I didn't even read the other ones, because it's according to, I don't know, how much CPU, how much RAM. This is what defines the unit per minute cost. 10. You plan to use Cloud Vision to analyze images and extract text seen in the image. You plan to process between 1000 and 2500 images per hour. How many VM? Again, as we said many times, serverless, so none. You have to run a number of services to support an application. Which of the following is a good deployment model? So run on a large single VM? No. Use containers in a managed cluster? This is probably the case. Use 2 large VMs, making one of them read-only? I would say no. Use a small VM for all services and increase the size of the VM when CPU utilization exceeds 90%. This is not really a good practice, so B. You have created a VM. Which of the following system administration operations are you allowed to perform on it? Configure the file system? Yes. Patch operating system software? Also. Change file and directory permission? Also. So it's all of the above, as I said before, everything you can think of basically. Cloud File Store is based on what file system technology? It is based on NFS, because we said it before, because we never named all the other ones. When setting up a network in GCP, your network, the resources in it are treated as what? I think it is not really well written, but should be understandable anyway. It is a virtual private cloud, right? It is what we talked about before. When you set up the network, you basically create a VPC. You need to store data for X, and therefore you're using a cache for Y. How will the cache affect data retrieval? A cache improves the execution of client-side JavaScript? No, we don't even know if the cache is on the client or not, so no. A cache will continue to store data even if power is lost, improving availability? No. Caches can get out of sync with the system of truth, so this is theoretically true, but let's read also the D. Using a cache will reduce latency, since retrieving from a cache is faster than retrieving from SSD or HDD. This is also true. Since here we're talking about how does it affect data retrieval, it is actually D, because, this talks about data retrieval, not C. So that is why it's D. Why can cloud providers offer elastic resource allocation? Cloud providers can take resources from lower priority customers. Imagine if it was the case. Absolutely not. Extensive resources and the ability to quickly shift resources between customers enables public cloud provider to offer elastic resource allocation more efficiently than can be done in smaller data center. That's true. They charge more the more resources you use is also true, but it doesn't say, it is not the question for this answer, so it's B. What is not a characteristic of specialized services in GCP? They're serverless. No, this is a characteristic, so no. They provide a specific function. This is also true, so here we're asking for not, so it's not the answer. They're requiring monitoring by the user. This is not a characteristic because they're serverless. You don't have to do monitoring. It is done by GCP in case for you. They provide an API. This is true, so it's C. Your client's transaction must access a drive attached to a VM that allows for random access to parts of files. What kind of storage does the attached drive provide? So since you need random access to parts of files, this should be block storage, because it's part of files. If it was just files, it could have been also object storage. And it's not D, because this says only SSD storage. It wouldn't be only, right? It could be also AirDrive, for instance. You're deploying a new relational DB to support a web app. Which type of storage system would you use to store data files of the DB? As we said, DB use block storage. Data storage is not something we talk about. I don't even know if it exists actually. Probably not. 20. A user prefers services that require minimal setup. Why would you recommend cloud storage, App Engine, and Cloud Function? So what do they have in common, these guys? They are serverless, and so it means that they require minimal setup. They are charged only by time, but I mean, even if it was true, it doesn't mean that they require minimal setup. They require user to configure VM. It's basically the opposite of what we are asking, and they can only run application with Ringo. Is absolutely not true. Other round of questions. You plan to deploy a software as a service application app for clients in America, Europe, and Asia. To maintain scalability, you need to distribute workload across servers in multiple regions. With GCP servers, would you use cloud load balancing to distribute load? You decided to deploy a set of microservices using... Oops, sorry, of course, that's again valid as for before. Before I click, remember to stop the video, right? So that you can answer by yourself. You decided to deploy a set of microservices using containers. You could install and manage Docker on Compute Engine instances, but you'd rather have GCP provide some container management services. Which two GCP services allow you to run containers in a managed service? App Engine standard environment and flexible? No, standard environment is not containerized. Kubernetes Engine and App Engine standard? No. Kubernetes Engine and App Engine flexible environment? Yes. App Engine standard? No. So, C. Why would an API developer want to use the API API platform? To get benefits or routing and rate limiting? Yes. Authentication services? Also. Version control of code? No. So A and B. You are deploying an API to the public internet and are concerned that your service will be subject to distributed denial of service attacks. Which GCP service should you consider to protect your API? Cloud Armor. All the other ones aren't related. You have an app that uses a pub/sub message queue to maintain a list of tasks that are to be processed by another app. The app that consumes messages from the pub/sub queue removes the message only after completing the task. It takes approximately 10 seconds to complete a task. It is not a problem if 2 or more VMs perform the same task. What is a cost-effective configuration for processing this workload? So Dataproc and Spanner are totally unrelated, so the choice is between standard VMs and preemptible VMs. Since it talks about cost-effective configuration, standard VM, of course, it will work, but let's try to understand if preemptible VM would also work, because if it does, it's more cost-effective. And it actually does, because for the requirement of our application, there is nothing saying that the task has to be performed immediately after we receive the message. Also, it's not a problem if 2 of them do it together. It's not a problem if one of them gets shut down because the other one can do it. So that's a perfect use case for preemptible VMs. Your department is deploying an application that does a database backend. You are concerned about the read load on the DB server and want to have data available in memory to reduce the time to respond to queries and to reduce the load on the DB server. Which GCP service would you use to keep data in memory? Of course, it's memory stored. That's easy. The Cloud SDK can be used to configure and manage resources in which of the following services? Compute Engine, Cloud Storage, Network Firewalls, or all of the above. So the Cloud SDK, if you remember, it's basically the SDK that you can install and run commands with. So basically you can use it with everything. So it's D. What server configuration is required to use Cloud Functions? VM configuration? No, because they are serverless. Cluster configuration? No, they are serverless. Pub/sub? No, so none. You have been assigned the task of consolidating log data generated by each instance of an application. Which of the stack driver management tools would you use? So if it's just log, consolidating log, it's the logging. The other one, the debugger is not really related. Monitoring a trace, maybe I didn't talk about trace. Well, anyway, they are kind of related to logs, but this specific case is just logging. Which specialized, again, remember to stop and answer by yourself. I'm super sorry, I think I covered the previous, I covered the previous question. Sorry about it, I forgot to remove my stupid picture. I will put it much smaller here. Okay. Which specialized services are most likely to be used to build a data warehousing platform that requires complete extraction, transformation, loading operation on batch data, as well as processing streaming data? Well, this is data analytics, right? It's not APIG, is absolutely not. Machine learning, we didn't say we need to do machine learning on it. Cloud SDK, no. So data analytics. Your company has deployed 100,000 Internet of Things sensors to collect data on the state of equipment in several factories. Each sensor will collect and send data to a data store every 5 seconds. So that's a lot of data. Sensors will run continuously. Daily reports will produce data on the maximum, minimum and average value for each metric collected on each sensor. There is no need to support transaction in this app. Which database product would you recommend? So I think the ECND are absolutely not possible, but also Cloud Spanner isn't really adapt to this use case. This is more Cloud Bigtable, which can handle a petabyte of data, if you remember, and anyway, in this case, we don't need, NoSQL is fine for what we need to do. We don't need to do any, we don't need to have any relational DB. You are the lead developer on a medical app that uses patients' smartphones to capture biometric data. The app is required to collect data and store it on the smartphone when data cannot be reliably transmitted to the backend application. You want to minimize the amount of development you have to do to keep data synchronized between smartphones and backend data stores. Which data store option should you recommend? As if you remember, again, when we have unreliable networking, it's Cloud Firestore. A software engineer comes to you for a recommendation. She has implemented a machine learning algorithm to identify cancerous cells in medical images. The algorithm is computationally intensive, makes many mathematical calculations, requires immediate access to large amounts of data, and cannot be easily distributed over multiple servers. What kind of compute engine configuration would you recommend? So normally, when it's really computationally intensive, and especially in this case, it makes many mathematical calculations, you don't only need a CPU, but also GPU are very important in this case. Moreover, since we need to deal with a large amount of data, this data, they need to fit in the RAM, right? So basically we need high memory, high CPU and high GPU, all of them. Then, you're tasked with mapping the authentication and authorization policies of your on-premises application to GCP's authentication and authorization mechanism. The GCP documentation states that an identity must be authenticated in order to grant privileges to that identity. What does the term identity refer to? So the identity, if you remember how I explained it, basically the person, but it's not, doesn't have to be a person, can be also software, can access something with a determined role. The person is the identity in this case, so it's the user. The user can have a role. The role is a set of privileges, basically, and the VMID, it's totally related, so user. A client is developing an application that will need to analyze large volumes of text information. The client is not expert in text mining or working with language. What GCP service would you recommend they use? So since it's text information, it's Cloud Natural Language Processing, even if we didn't talk about them in detail, you can still understand it is Cloud Natural Language Processing. Data scientists in your company want to use a machine learning library available only in Apache Spark. They want to minimize the amount of administration and DevOps work. How would you recommend they proceed? So we didn't mention Cloud Spark. There is Cloud Dataproc, there is BigQuery, and there is install Apache Spark on a cluster of VM. But since we want to minimize the amount of administration and DevOps work, D is not the response. BigQuery doesn't have anything to do with Spark, so the answer is B. Database designers at your company are debating the best way to move a database to GCP. The database supports an application with a global user base. Users expect support for transaction and the ability to query data using commonly used query tools. The database designers decide that any database service they choose will need to support ANSI 2011 and global transactions. Which database service would you recommend? So, Cloud big table is not the best way in this case, right? Because, well, we need transactions, we have a global user base, and since we have a global user base, also Cloud SQL is not fine. Cloud Spanner might be okay. And query data using commonly used query tools. So Cloud Data Store is also not fine. So the answer is Cloud Spanner because it's the only one that meets all the requirements. Then, the last 3 questions, guys, we are done for this lesson. Which specialized service supports both batch and stream processing workflows? It's not BigQuery. It's not AutoML because that's more machine learning stuff. It's not Cloud Data Store because from the name you can remember data store, it's a storage service. So it's Cloud Data Proc. You have a Python application you'd like to run in a scalable environment with the least amount of management overhead. Which GCP product would you select? So, I don't know what is Cloud Engine. It's not Kubernetes Engine because Kubernetes Engine you still need to have some configuration, let's say some management. So the choice is between App Engine Flexible and Standard environment, but to have really the least amount of management overhead, since you're talking about a Python application, then the standard environment is better. Since for the flexible one, you also need to have it containerized, and there is so a few more configuration to be done, a little more configuration to be done. Last questions, and we are really done for today. A product manager at your company reports that customers are complaining about the reliability of one of your applications. The application is crashing periodically, but developers have not found a common pattern that triggers the crashes. They are concerned that they do not have good insight into the behavior of the application and want to perform a detailed review of all crash data. Which Stackdriver tool would you use to view consolidated crash information? So, okay, Dataproc is unrelated. Then we have monitoring, logging, and error reporting. That they are kind of related between each other, but in this case, we're talking about the fact that they didn't find a common pattern. So monitoring probably has already been done. And also we are only talking about crash data. So they don't care about logging in this case. I mean, monitoring and logging are very important, right, to find the common pattern. But for the way the question is posed, we understand that they're talking about error reporting. So guys, that was it. Thanks a lot for the patience. So this is basically a very high overview, of course, of all the Google Cloud services, but that is needed if you want to do the associate certification. That is absolutely needed, and trust me, it will be useful. And trust me also, the next lessons will be much more entertaining because we will finally put hands on Google Cloud and it won't be just theory. Thanks a lot for following. Ciao!